Today we are going to graph systems of linear inequalities. And let's go over some rules with graphing inequalities. And there's two things we need to concern ourselves with. And the first one's line type. So remember, we have a solid line. Solid line when we use one of these two symbols, either a greater than or equal to, or a less than or equal to. And so whenever it has that line underneath, that's when we're using that solid line. Now use a dashed line whenever we have one of these two, either greater than or a less than symbol. So remembering the key thing is, if it has the line underneath, it's a solid line. No line underneath, it's a dashed line. And what that represents, the solid line means that the solutions are on the line along with being either above or below. Dashed means the solutions are not on the line. They're either above or below. Well, we also have shading. So if I sketch a little coordinate plane, xy axis, here's my y-axis. Now, we're either usually going to shade above or below the line, but we could also shade left or right. So let's take a look at this. So if I have this line right here, anything above the line is on this side where the y values are bigger. So here, whenever we have a positive y is greater than or greater than or equal to, this is the side that we would end up shading. So we'd shade above the line. I treat that as above because if you put a person on the line, above his head is above the line, below his feet is below the line. Well, let's take a look at another example. If we had another line, another coordinate plane, and this time it looks like this. The line goes this way, and here's the y-axis. Remember, again, when we're talking about this, it's the positive y values. Positive y values, let's say, are less than or less than or equal to. Less, well, these are the less y values. These are the lesser y's. So what we do is we shade below. So below represents the possible answers, not above. But we could also have to shade left or right if there is no y. So if we have no y term, then we're either going to shade left or right. So let's look at an example here. And we have no y term when our graph looks like this. There's our coordinate plane. Let's say it's a vertical line, straight up and down. You can't shade above, you can't shade below because the line goes forever above and forever below. But we could shade left or right. So we're going to end up shading on the side that is to the left when it's an x is less than or less than or equal to. That is left. So less means to the left we'd end up shading. But if it's an x is greater than or equal to, those are bigger y's. So bigger y's means that we're going to end up shading to the right. So greater than or equal to, you shade to the right. And if it is a less than, x is less than or equal to, we're going to end up shading to the left for the vertical line. So let's take a look at our examples here. First one starts with a -1 for the y-intercept. So we start with that point, and we plot that. So we're going down one space, put the dot there, and then use the slope. The slope tells me to go up, but then the 2 tells me to go to the right. And so up 1, 2 to the right. Do that a few times, gets you on that line. We can also go the other way, go down to the left. That gets us on that same line. Well, looking at the line type, there's no line underneath, so it's a dashed line. So we'll end up drawing those dashes in there. Now, we can also shade. Now, before I shade, I'm just going to draw arrows in the direction that I would shade. It's a positive y is less. Less means we're going to go to the left. Or actually, less means left when it's a vertical line, but it's not vertical. So less, in this case, for the y values, is below. So I'm going to shade below, but instead of shading, let's just draw some arrows. We'll shade at the end. You'll see why when we draw this next one. Well, the next one is just a horizontal line. See, there's no x term. So we're going to start with the y-intercept of +2, and then we're going to draw some points. Now, the points, you don't go up, but you do go over. And so when there's no x term, there's no slope. Well, there is actually slope. The slope is 0. What we can do is we can just draw a horizontal line. Now, it is a line that is solid because it has the line underneath. So what I want to do with this blue line is I need to extend that a little bit. See, I don't see the different areas that they cross. See, if I extend that a little bit past that graph that I have and extend this one out too. Extend that one out further. Now you can see the different regions. See, we have 4 regions. We've got a region up here, a region here, region here, and a region here. Well, for the blue line, it has to be below, so it's not going to be this one. It's not going to be this one. So it's going to be one of these 2 regions. So again, I can shade below that blue line, so in this direction here. So let's take a look at this purple line. Well, it says y has to be greater than. Positive y is greater, so this means we're going to end up shading above this line. So when I go ahead and draw the arrows here, they need to go in this direction. Well, over here on the left-hand side, I can't shade on this side because I'd be above the blue line. So I can only shade where the 2 lines agree, which is only in that region there. So that's our first one. Let's take a look at the next one. Let's say we have there's no y term here, so there's only x. So remember, when there's no y term, that means we have that vertical line. So it's going to go right through x at 1. So I'll put a dot right there, and then it's just a vertical line. Now this is a dashed line because we don't have the line underneath. So I'll go ahead and start drawing those dash marks. And draw it nice and long. There we go. I didn't draw the last one long enough, so I'm going to draw this one nice and long so we'll see where it crosses. So those are my dashes, or my dots. And now let's take a look at the next one. Here we do have a y-intercept. It's positive 1. Go up there. And then use the slope. Slope in this case is 1 to 1. So you're just going to go up 1 and over 1 each time. And you just do that a few times so you can see the regions. Do that on going down as well. It could go down to the left. Alright, so we got a bunch of dots. We can draw the dashes. And then from there, we can go ahead and look at which directions we should be shading. So let's go start with our purple line, since that's the one I'm on. And it's a positive y is greater. So this means I end up shading above. Above. The greater values of y are this direction. Those are bigger y values. Smaller y's are down below. Well, taking a look at this line here, this is x is less. Less means left. See, I can't go above because I've got a vertical line. But I can go left or right. And so less means left. And so left is this way. And these are smaller x values are off to the left. Well, I can't shade down below because I have to be above the purple line. So the only region I can end up shading is just in this region that is to the left of the blue line and above the purple line. So those are the possible solutions. So every point in that shaded region, those are answers. Those are solutions that will work. Anything else won't work. Well, let's take a look at the next one. Here, there's no value that's being added to the x term, so you can always add 0. So 0 is where the line starts. That's the y-intercept. The slope is 2 to 1. So what that means is you're going to go up 2 and to the right 1 space. And do that a bunch of times. Also go the other way, down 2, left 1. And then from there, we can go ahead and draw that line. And so we can draw that line by just sketching that in there best we can. And then from there, I can figure out the shading. It's a positive y is greater. Greater means y values that are greater are above. Above goes in this direction. So then let's take a look at the next line. The next line, well, we got to get y by itself. And you're going to see this on one of the problems. You're going to want to get y by itself. And the way we're going to do that is just subtract that x term. Move that x term over. Let's rewrite what we'd have. So when I rewrite that, I've got y is now greater than or equal to negative 1/2 x plus 3. So now I've got it in the slope-intercept form, so I can go ahead and graph it. So I'm going to start with the positive 3. That's my y-intercept of 3 spaces, and put the dot there, and then use the slope. This time the slope is negative 1 to 2, so that means down 1, 2 to the right. Do that a few times. Get some points on that line. Go also the other way, up 1 and over to the left, and then draw that line. This is another solid line, has the line underneath. Now let's figure out the shading. So here, it's a positive y is greater. Greater means above. So another above the line one. So this above would be this direction. See, I can't go down because those are going to be smaller y values. These are smaller y values here also. So I need to be above. So I need to be above both lines. And so the only region that would work is where the two arrows agree. So it would be all in this region up in here. Well, that's an example of some of the problems. We'll go over some more in part 2.